This is video 3.7. The goal of this video is to solve a system of inequalities by graphing. So what we need to understand is the goal is to shade in all solutions to all the inequalities. The key word here is the all. All the inequalities, all the solutions. So when we're given a system, we're given multiple inequalities, we want to shade in the solutions that work for all of them. Not just the solution that works for one or two, but all of the inequalities that we're given, all of the rules that we're given. So let's see this in action so you understand what I'm talking about. So first of all, our steps. So our first step is always to get the equation in slope-intercept form. Okay, so I'm going to model that with the example, and then we'll look at step 2. So I see these two equations. I have a red and a blue. So I'm going to start with the red. And in order to graph it, I need it in y equals mx plus b form. So what I do is I change the inequality to an equal sign, and then I simply solve for y, because I want the y alone, as you see in the step 1 instruction. So I'm going to subtract 3x and get the y alone. One more step, I'll divide by 4. So now my y is alone. And I'm going to simplify that, negative 3/4x, and then this simplifies to negative 1. So I've written the red equation in y equals 4. So my next step is to do the same thing with the blue. So I'm going to do that quickly and have you do it at the same time, and then we'll check your work versus mine. So pause the video here, and then check back to see the solution for the blue one. You're solving the blue equation. Make an equation with the equal sign here. Solve it for y. Do that now, and then restart the video when you're ready to see the solution. So here's what you should have gotten. You should have gotten y minus 1/2 x, or maybe you wrote it as negative 1/2 x plus 1. That's the same rule. Now remember the 1/2 is there because when we do x divided by 2 here, it's really 1x, so that's where we get the 1/2. So we have our two equations in y equals form, and now we're going to move on to step 2. And step 2 involves graphing. So what we're going to do next is set up our graphs. So before we do that, we have to think through what they're going to look like so that we don't have to deal with erasing. So here's what we need to remember, that we use dotted lines. So we're talking about dotted lines like this when we have symbols less than or greater than. Greater than and less than. But then we use solid lines when we have symbols less than equal to and greater than equal to. When we have those, we're going to use a solid line instead of a dash dotted line. So remember, that's all about whether or not we can equal the line. So I look at my symbols here, and I see that they are both symbols that involve dotted lines. So I'm going to use dotted lines for my lines. So I'm going to graph them now using what I remember about graphing lines, and I'm going to graph them on the same graph. So for the red one, I'm going to start at negative 1, and I'm going to use a slope of negative 3/4. So I'm going to go down 3 over 4. And I'm going to do that again, down 3 over 4. And of course I can repeat it backwards. Backwards 4, up 3. And I'm going to connect this with a dotted dashed line. So once again, I'm going to have you pause the video, and I would like you to try and graph the blue line, and then check back in the video to see if you did it correctly. So when you graph the blue one, you should have started at 1, as you can see me putting in green here. You should have started up at 1, and then used a slope of negative 1/2. So down 1 over 2, down 1 over 2. And that's how you should have gotten your blue line, and again, you can work backwards to get some points to the left. So that's our red and blue line. We have step number 2 complete. Step number 3 is finding the solution region. This is the shading in. So here's what we need to do. We need to shade for each line after testing a point. So we pick a point just like we've been picking and we shade accordingly. So just like when you graph inequalities. But I want you to be careful when you shade because what you need to remember is that the solution region is where both rules have been shaded in. So we only want to shade in there, extremely dark. So where both rules have been shaded in. And that's key, both. Okay, both of them have to be shaded in. So I'm going to shade very lightly, and I'm going to keep with my colors here to help us keep it straight. I'm still going to pick 0, 0 because it's my favorite point to pick. So I'm going to test 0, 0, and I'm going to go back to the inequality. So I do not want to use my equations that I rewrote to help me graph the line. So I'm going to go back to 3x plus 4y greater than negative 4. And I'm going to plug 0, 0 in. So 3 times 0, 4 times 0, greater than negative 4. And I'm going to test if this is correct. And on the left, I get 0, which is why 0, 0 is so nice. And on the right, I get negative 4. And then I read the statement, 0 greater than negative 4. And I say, hey, that's true. So the red line is going to be shaded towards that 0, 0 point, that green point. So that means I'm going to shade above the red line. So I'm going to shade up here above the red line. That's the red solution region. But I'm looking for where red and blue are both shaded. So now I have to do the same thing with blue. So I'm going to take my blue equation, and I'm going to plug in 0, 0 again. But now into this rule. And I'm going to test if it's true. 0 less than 2. This is also true. So now my blue is going to shade towards the 0, 0. Remember, that's the green dot here in the middle of my graph. So I'm going to shade from the blue line is going to go below. This is the blue solution region. So remember, the actual solution to my system is where they intersect. So in our case, it is this section here, where they're both shaded in. It's this little tiny sliver. Because that's where blue and red were shaded in. So that's the region that I would shade in to show my solution. I'm going to shade in this region right here, extra dark, because that's the solution to my system. The other two shadings I'd actually kind of want to erase. I'd want to erase these because they are not solution to the system. Only that dark area that I darkened. And that's how you're going to graph your systems. You're going to find the region where they're both solutions and shade it darkly. So give this next one a try, and then you can check back in the video. So pause the video, try this one, and then check back and see if you got the same solution region. It's very important you shade exactly where the solutions are, not any more or any less. So give this one a shot and then restart the video when you're ready to see the solution. So check your graph. Did you get the same graph as me? I have the blue and the red line. The red line is 2x plus 1, as you can see down here, and the blue line is x minus 2. For the blue line, I shaded below the blue line, kind of to the right over here, as you can see. And for the red, I shaded up and to the left. So I looked for where they cross, and now you might be better shaders than me, but do you see where they cross on my graph? It's just down in this little sliver. This is my solution region. This is the space that I darkened, because they both were shaded in that region. Over here, it was just blue. On this side over here, it was just blue. Here, nothing was shaded, so that's obvious. That's nothing. That's not part of my solution. Here, it was only red, and it was way down on the bottom, way down here, that it was both blue and red shaded. So that's my solution region, and in fact, I should probably erase the other blue stuff and the other red stuff because it's only a solution to one of my equations. And I want to darken in the one area where it is a solution. So be prepared to kind of shade lightly at first and then darken in the area where they're both solutions. So you just darken in that one little section. If you didn't get this one right and you couldn't figure out why not and you have questions, ask your teacher. Otherwise, try the next problems on your own and be sure to ask questions as you go and get your answers checked along the way. Okay, good luck and be careful with your shading.